Hi everyone, I'm Tracy Smith from Finding Physics. Today I want to talk to you about the problem-solving method. This is such a key component when you're starting off in a physics class. And the method that I'm going to show you today is a method that I use in my classroom, and your teacher may have a different way of showing the problem-solving method. In the end, what we're trying to do is give you something that you can count on when you work on any problem in the physics class. So the first thing I want to say before we jump into all the different steps of the problem-solving method is that we're trying to create a routine here. Just like you wouldn't be thrown into a basketball game without ever practicing basketball before, you can't be expected to be given a physics problem that is complex and know how to approach it unless you've been working on a bunch of basic problems using techniques that you've mastered to handle the harder problems. So what we try to do at the beginning of the school year is teach you a method to use on the easy problems all the way up to the most challenging problems so that you can count on it. You're ready. You know what to do when you're put in an unforeseen situation. So we're working on finding a routine here, guys, and that's just what the problem-solving method is. And by following this method, even times when you feel like, what is this problem? How am I supposed to do this? If you just start going through that problem-solving method, it's going to lead you to the answer. Okay? You just have to kind of have faith and follow along. So here it is, the problem-solving method I'm sharing with you today. I'll read through them quickly now, and then I'll go through each point. So first you need to read the problem, then draw a sketch or diagram, list your known and unknown variables, list equations, manipulate equations, plug in numerical values, solve, and then communicate an answer. So let's go through each of these. The first one, you can laugh if you want. You have to read the problem, and you may be thinking, of course I do, but you know you don't read the problem a lot of the times. So many people scan and they're just looking for numbers and they're not paying attention to what the problem is asking. If you're in these higher level physics classes, the AP physics, the IB physics, you need to realize that that question is really important. And if you go through a whole bunch of work that could be correct, but you don't answer the question, you're not getting the points for what it is you solved. The verbs mean something. Sometimes the problem may say solve, or it may say state, explain, compare. All of these words are critical, and if you don't catch them at the beginning of the problem, you may start down the wrong path. So whenever you're reading the problem, I do a lot of active reading. I suggest students, whenever they're reading, get your little highlighter out, highlight things, or maybe circle words that are key words that you know that means something important and you don't want to forget later. So as you're going through and reading the problem, you definitely should be doing active reading and really paying attention. And I know, I'm with you. When there's a problem and it's like the explanation is 3 paragraphs long, you're like, oh, do I need to read all this? Yes, just take a deep breath, get your mind in the right place, and start reading. After you read the problem, draw a sketch or a diagram. You do not have to be a great artist. I am not. Here is my go-to drawing right here. This is the most common drawing that I make, my stick person. I draw stick people all the time, but really anything so you can visualize what the problem stated. Maybe, something is a ball was thrown horizontally and I want to see what's happening, the movement of that ball. Something so you can visualize the problem that's given to you. A little bit later on in the school year, there are special diagrams that we do called free body diagrams. We use them when we're creating problems that deal with forces, and there are special rules for those, and we kind of draw forces on depending on which way forces are acting on, and we label them, all this good stuff. So that's a special type of diagram that shows up a little later in the school year, but just to start, even sketches help. Something little, quick, that gets the point across and helps you visualize what's going on in the problem. Next, Now you look at the problem and you find the variables that they gave you. And you make a list of known values and unknown values. So I sometimes will start off on the left side of my paper underneath my sketch or diagram, and I start listing, oh, they gave me a displacement, and I list, whatever that is. Maybe they said something about 6 meters. Maybe they gave me a velocity of 4 meters per second. I don't know. I'm just making up random stuff here, but you need to list your variables. And then you need to list what it is that they ask you to solve for. What's the unknown? What's the purpose of your problem? What are you trying to figure out? Maybe it was something with time here and they wanted to know something about time. And so what I usually do with my unknown is I write down the symbol for that variable and I put a question mark next to it. So I remind myself what it is I'm actually trying to solve for. Maybe your problem has multiple things they want you to solve for, so I put them all down. Maybe there's a step A, B, or C. But right now we're working on organizing information so it's easier for you to find as you go through this problem solving process. So here, the idea, list what they give you in the problem and then list what it is you're trying to solve for. Now, this next step builds on knowing what your knowns and your unknowns are. Now that you have a list and you can clearly see in front of you what information you have and what you don't have, now you can go to an equation sheet or your book or whatever and find equations that deal with what you're currently learning. So you would want to find an equation that has the thing that you don't know, the thing you're trying to solve for, and variables that you know. Now, if you're lucky, maybe it's one equation. Yay! In that one equation, you just found it. Look, there's all my knowns, my unknown. I found the equation. Sometimes it's not that easy. Sometimes you need to kind of get a collection of equations that may or may not work for this problem, but you just write them down as you find them on your equation sheet. Okay, so maybe you have an equation you found that says V is equal to, I'm just writing it this way, delta X over delta T. I know I didn't write it that way on the previous slide, but you find this equation and you say, oh, I was given V. That was listed in my problem. And I was given delta X. The problem asked me to solve for T or delta T. Oh, this might be the right equation. So you luck out, you kind of find this equation, you're like, yay, got the equation. Now, the next thing, right now we're just listing it as we found it on the sheet. The next step is to manipulate the equation. What does that mean? That means if you looked at the equation that I just wrote on the previous screen, you were trying to solve for delta T, for example. But that equation wasn't set up to solve for delta T. Now's the time that you rearrange the equation with the variables. I know right now you're thinking, can I just plug in the numbers and then solve it and rearrange it? Nope. Good physics practice is that you manipulate the equation with the variables in it. This is helpful in a lot of ways, guys, and a lot of beginner students want to fight this, but I promise you in the end, it helps you out so much if you do the manipulation with the variables up front. Okay, so you're going to go through, you're going to do your algebra, and after you've gone through, manipulated your equation, now's the time to plug in the numerical values. Now you can plug in all those numbers now that your equation is set up and you had already manipulated it, and we'll say it says delta T is equal to delta X divided by V. So that's what you did on the previous slide. I'm not going through all the steps for this silly little example I'm giving you, but you now have something set up to solve for T, and that's what we wanted to solve for. We're all excited here. And you just plug in the numbers. But I'm going to warn you, sometimes plugging in the numbers is not as easy as it may seem. Sometimes when you plug in the numbers, you need to stop and say, okay, what's the order of operations that I need to put this in my calculator? This is a nice, easy one, but sometimes the equations get a little complex and you need to make sure you put the numbers in the right order. Another thing that you have to watch out for whenever you're doing this, and really I probably should have mentioned this at the beginning, you need to make sure that all the units of your variables agree. So like you're not trying to mix meters and centimeters. You should take care of that at the beginning whenever you're listing your variables. Make sure everything agrees with your units. And there is just at this point in time, maybe even your mode for your calculator. Are you doing something with angles? So you should check to see if you're in degree or radian mode. So even though you're just plugging in the numbers now, there are a lot of things that you have to kind of make sure you're aware of whenever you're plugging your numbers in. And then solve. Go ahead, put it all in there, get an answer, put your answer down. Now, whenever you're solving and you're stating an answer after you've solved it, you always have the number and then the unit for that value, because whenever we're solving, we always have to consider our units. There are a few things that you may solve for that don't have units because they end up being a ratio and the units cancel out. But overall, typically we have units. This is a huge thing that students make a mistake of, especially at the beginning of the year. You're so excited. Yeah, my calculator gave me a number. You spit out the number and you forget to put down what that answer is measured in, which is a critical part of the answer. So whenever you're solving, not only do you put what the calculator spit out, but you also have to put down the units. One other thing that you have to watch out for, and this depends on your teacher, your class, what the problem is, sometimes you need to make sure you are recording your answer to the proper amount of significant figures. I'm going to have a mini lesson on that on its own, but you can't just always put down whatever the calculator spits out at you. You need to go through and think if that is logical, that your answer would have that much precision in it. So this part, you do have to watch how you're recording your answer there when you solve and you put your information into your calculator. Last but not least by far is how you communicate your answer. And communicating your answer is a really big deal, especially if you're taking things like AP or IB physics, because you have to now go back to the beginning. You have to look at that problem and say, what is it that they actually asked me? And am I addressing their question? And a lot of times they don't just want you to spit out a number with units on a page. They want you to describe. They want you to explain. They want you to compare. So your job is not yet done until you've gone back and addressed what it is that they asked you to address in the first place. So at the end, even after your calculator gave you your answer, you wrote it down, go back, reread that problem, and make sure that you answer it the way it should be answered. And this part right here, guys, this is where there's more of a focus in these higher level physics classes. And this is where it really makes or breaks the problem. In physics class, typically you can get a lot of partial credit as you go through the problem solving process. But this communicating the answer is so key. It shows that you understand what you just did and how it relates to the bigger picture. So this takes a lot of practice on communicating, and different questions require different types of communication. Maybe they want you to outline or just put bullet points and explain something. Maybe they want you to compare two different scenarios. Maybe they want you to say if something is going to make it to the next step, or if somebody's jumping, if they're going to clear a building, or do they have enough time to do A, B, and C? And you have to use your answer to say, yes, this person can complete this in enough time. So really communicating the answer is a really big thing. Now, I know I just quickly went through the different steps of the problem-solving process. When are you going to use this? Every stinking day, folks. Anytime you get a problem, you should be going through this process. Sometimes you may be there might not be a lot to do with a step, but you should still acknowledge that step and see if it applies to the problem you're using. Do you really need to go through each step? Yes. Yes, like I said at the beginning, you're trying to build this routine. You're trying to get this process so that when you get to those hard problems as the year progresses, you have a foundation. You know what steps to follow in order to lead you to the right answer. Because at the beginning, it may seem straightforward. And you're like, oh, look, I got that. There's the answer. Bam, I got this. But as the year progresses and these problems become more and more complex, you really need to make sure you're not missing any of these steps, because they will help show you the path to solve the problem. Even if at the very beginning it's unclear to you, you can see it unfold as you go through the different steps in the problem. If you were to take a Finding Physics workshop on problem solving method, all I'm doing is practice, problem after problem, talking through those different steps and showing you, look, here we go. Step 1, step 2, step 3. And in the end, after doing it so many times, you don't even see it as steps. You're just used to it. It's part of your routine. But that's what we need to do to get you familiar. And guys, I cannot emphasize enough the importance of following this problem-solving method. It is so key to helping you feel confident and comfortable as you go through a physics class. So start right off the bat, right at the beginning, start following this problem-solving process. All right, well, if you want more help from me, visit my website, findphysics.com. You can find information about tutoring sessions, workshops, and different physics tips through my blog, or listen to the Finding Physics podcast. I have some information there, some inspiration, different things to kind of keep you thinking and reminding you that you are not alone in this process, and it is a worthwhile thing to go through. Finding physics can change your life. I hope you all have a great day. Bye.